Is your machine working well enough to survive a descale? Hello everyone. Today I'm going to talk about an age-old problem that I think almost anyone with one of these dual boiler machines has either experienced themselves or at least heard about, and that's the descale problem. I say problem, but it really is a disaster. This is the first time I've actually taken the time to do any kind of research into this, so I wasn't really sure what to expect. But what I found really surprised me, as it's generally accepted that descale solution contaminates the probes. However, after testing this, I found it actually made very little difference, and that the real problem was there all along before the descale. So in this video I'm going to share everything I've learned, the methods I used, and then at the end of the video I'll show you a technique you can use to test if your machine is in good enough condition to be descaled. Yes, you heard that right. Before we carry on though, I should just mention that some parts in this video require you to open the lid of your machine, so make sure you are allowed to do that where you live. If not, then please get a qualified technician to carry out these repairs. For the rest of you, it goes without saying that there's mains voltage running through parts of these machines, so take extra care when following along. So, what is the problem with descaling these particular dual boiler machines? Well, there are a couple of different outcomes when you run a descale. Number one, everything goes smoothly. You pat yourself on the back and convince yourself your coffee now tastes at least 30% better. Or number two, and probably the reason you're watching this video, the process finished, but now your machine doesn't work. And quite often, it's too expensive to repair. And this is the very reason a lot of you out there choose not to descale at all. It's been a persistent issue for Breville since the birth of the dual boiler back in 2011. And while they've made some improvements to help fix the problem, in some cases, like the machine I have here, they seem to have actually made it worse. So why bother, you ask? If there's any risk I'm going to essentially brick my £3 machine, then why take it? I'll just use filtered water instead. Well, there is a good argument for that and it should work okay, but just don't use anything purer than your basic spring water. It's due to the way these machines need sufficient minerals to sense the water correctly. However, even with filtered water you're going to need to descale eventually, and this is because this will happen. The biggest reason to descale in my opinion is to prevent the steam boiler inlet port from becoming blocked like this one, as this can eventually lead to the same very expensive repair as the failed descale could. Another problem is the element. If it gets too bad like this one, it's going to struggle more to get the boiler to steam temperature. So the takeaway from me is that you really should try to descale if, and this is a huge if, your machine is working correctly. And what's the first thing most people do when their machine isn't working correctly? Yeah, descale. So, on that happy note, let's go through some basics of how the steam boiler works so you'll be more equipped to troubleshoot your own machine and be able to make a decision on whether you descale or not. And if you choose not to go through this process, which I don't blame some of you for not doing because that does come with some risks, at the very least, get a professional to do it. Let's start by looking into how this works. Inside the steam boiler are 3 sensors. One is connected to ground and the other 2 are just used to measure when the water is too low or just right. You can see all this in action on this machine where I've disconnected power to the heater and moved all the sensor probes into an external jug so you can get a better view of what's going on. I'm going to use the live debug mode this machine has so you can get a clearer view. Let's start with an empty boiler and let's switch the machine on and go into debug mode. To do this, hold down the power button and then switch on at the wall. Enter 5 zeros and then choose the live debug menu. You can see straight away that the machine has noticed the upper probe is dry and told the pump to switch on. Once the water reaches the lower probe, you'll see the AD count drop, and then you'll also see that the heater comes on too. And then you'll see the high probe value drop down and the pump will stop. Keep those AD values in mind as they're going to play a very important role later in the video. So that was how everything is supposed to work. How does it look when things go wrong? Okay, a few things can go wrong during a descale, and these usually occur just before the rinse stage when the boiler's empty. Number 1, the boiler stays cold and empty. Here, the red probe thinks it already has water in, so it doesn't tell the pump to turn on. Because the blue probe's working okay, that means the heat doesn't come on either. This is the best case scenario, as although the steam won't work, nothing is actually physically damaged. And you can usually fix this by cleaning up the red probe and turning it on again. Number 2, the boiler only half fills. You can hear it boiling, but the steam doesn't work. This can happen if steam gets into the red probe while it's still filling up. And because the blue probe is submerged, it's going to turn on the heat. But because there's only a little bit of water in there, it's going to get hot very quickly. So quick in fact that the little temperature sensor on top of the boiler is not going to have time to read how hot it's getting, and it's going to continue to ask for more heat. And eventually it's either going to trip the thermostat on the side or it's going to blow the thermal fuse. And then finally number 3, the element comes on and the boiler is bone dry. This is the worst case scenario. And this can happen if both those probes are playing up. And if you're lucky, the thermal fuse will blow, but quite often the element gets so hot so quickly that it burns through its own insulation, and essentially you've got to go out and buy a whole new boiler. Okay, so I think we've covered enough about the actual outcome. Let's investigate why this seems to be happening so much on these machines. In order to do that, we first need to understand more about how these probes function, so we can then work out when or how they are going wrong. The way these probes detect water is by sending through a small voltage of around 2 volts. If the probe is submerged in water, then current will flow through to either the ground probe or the side of the boiler, whichever is closer. The machine will measure the resistance of the current through the water to determine whether or not it thinks there is water present. This resistance value is set by the machine's firmware, and interestingly, which we'll probably cover later, it differs from various versions of machine. So, we know that somewhere inside the machine there is a set resistance value that it uses to determine if it's water or not. We need to find this value so that we can replicate the fault and hopefully solve the problem. To do this, I'm using a potentiometer placed in between the ground and the connector of the blue probe. If I slowly reduce the resistance, you will see the AD count falling. Eventually we'll get to that point where the machine thinks it has water and turns on the boiler. I don't think I got the exact number on this video as it took a long time due to it only taking a reading every 15 seconds, but I can reveal that it's around 1880. So now all we need to do is measure the resistance of the potentiometer to find out what that is in terms of ohms. And there you can see it's 1.3 mega ohms for this machine. Now I also did this same test on a dual boiler and the non-touch Oracle, and interestingly the set points on those were a lot lower. They were down around about 900 kilo ohms. So my next question is why? Why is this one so much higher than the other machines? If you think about it, surely that's going to make for more failures, and I'll explain why shortly. So now we have those magic numbers, let's try and replicate this on the benchtop. The reason I'm measuring these like this is because I discovered something on a machine that came into the workshop the other week, and it had blown a thermal fuse twice, both times during a descale. I asked him what descale solution he'd been using and he said it was just the Breville branded one. The machine was only 3 years old, so this got me thinking, as I assumed the descale problem was mostly fixed on the later firmware. After following this process I've shown in the video so far, I found something that didn't look right. The probes were measuring really low ohms, like about 500k. They looked almost new, and so at first I thought maybe they were from a bad batch or something. So to test that theory, I asked in a Facebook group, and someone kindly sent me a heap of probes from machines they'd serviced over the years, so these should give us a good sample to use. So what I'm doing here is wetting the probes in just plain tap water, then inserting them into a boiler and measuring the resistance. This is to replicate them being inside a boiler full of steam. I'm wetting the tops too to simulate probes that may also be leaking. Hopefully this covers all cases. I have a piece of paper dividing those that would certainly fail a descale and those that would pass or scrape by, as is the case for many of these. So I don't know about you, but I think those results are quite shocking. And just for comparison, these ones are brand new. Let's leave them to soak in tap water overnight and then we'll try again tomorrow. Well, that certainly seemed to do the trick, didn't it? They were much better, but still nowhere near as good as the brand new probes though. Now, let's put it to the ultimate test. Instead of tap water, I'm going to use a regular mix of Descale solution. I don't think it matters which brand, but this happens to be Breville's own one. So there's about a 50% failure rate. So that raises concerns as to how reliable these would be during a descale. So all we need to do now is try this same test out on some new probes. I think that proves in a semi-scientific way that while cleaning the old probes improves them, it certainly doesn't guarantee that they'll hold up during the descale process. From now on, I am personally going to replace probes on a much more regular basis given this. Just before we move on to recap, I just want to show you the probes from the latest Gen 3 boiler. These are a couple of years old almost, but you can see from this photo the difference when I coat them in water. They don't seem to be porous like the older ones can be, and they're actually made with plastic rather than ceramic. So why aren't they remaking the older ones with plastic? So let's recap on what we've found so far. We know that during a descale the hot water is emptied out and the steam condenses across the probes. We also know that on the Oracle Touch I have here, if that steam causes the resistance from the probes to ground to drop below 1.3 megaohms, then the machine will, depending on which probe is affected, either turn off the pump too early and or turn on the heat when there's no water in the boiler. If it's the red probe playing up, you may be able to fix this by either disconnecting the red wire for a minute or so to let it fill up, or you could take the probe out to rinse it off and dry it as well. You may also be able to fix it sometimes if there's enough water in the bottom of the boiler by tilting the machine 45 degrees. You've basically got to tilt it enough to get the water in the boiler up to the top of the probes. And I've heard it a few times, but Breville's help desk tends to offer this solution, but from what you've seen in this video, it's not a solution. The solution is to replace those probes. So before you all rush out and buy new probes, it's worthwhile checking yours first to see what kind of condition they're in. And this is actually really simple to do. and even more so on the oracles, as they give you the AD count in the debug menus. On the touch version, switch off the power at the wall, hold the power button down and switch on. Continue to hold until the password screen comes up. Enter 5 zeros and choose the debug menu. Scroll along to the Steam debug and let your machine heat up fully. You can see here now it's up to temperature that the blue one, which is the low probe, is very low, and then the red one is also very much below the threshold of 1880. I think the blue one's a lot lower because a lot more of the probe is submerged. What we're going to do now is drain the boiler for around about 5 seconds or so, which should be enough to drop the water level below that upper probe. And we should be able to see that on the reading there. And you can see on this one the numbers actually barely moved, so this would certainly fail a descale. I'm going to have to change these probes. And this is another example too on another machine, and this one it's kind of hovering around that set point of 1880, so these will need changing too. So that's how you would go about testing them on the touch. The non-touch is very much the same. To enter the debug menu on these, hold down the select and menu buttons until you hear the beep, and then press menu again. You can then use the long black button to scroll to setting 8, which is shown on the grinder LCD. And this will be the AD reading for the high probe. And then, like we've done before, use a flat bladed screwdriver to drain the steam boiler for about 5 seconds. Again, be careful not to burn yourself. And you can see that the probes on this one are okay. It's well above the 391 set point. I think if you're much below this, say around about 500, I'd be a little bit concerned about doing a descale. And then finally we have the dual boiler. It's a bit more difficult on this one. You can give it a basic test by draining the boiler, then listening out for the pump to come on. This will give you an indication if it's really bad. But the best way, if you're confident enough, is to shut down the machine after the draining part, take the lid off and disconnect the red wire to the probe, then measure the resistance with a meter. This machine has just had brand new probes installed, and you can see that it's measuring about 100 megaohms. So to conclude, let me know in the comments below, but I really think I'm onto something here with this, and I hope it's going to save a lot of machines from ending up at the tip. Make sure you check the condition of your probes, and if you're not comfortable at all with any of this, the next time you get yours serviced, mention to them that you want the probes replaced. They only cost around 40 to 50 bucks, and it could save you hundreds. Although the general consensus used to be that it was the descale solution that was the underlying cause of this problem, I think I've shown here that it's actually the condition of the probes themselves that matters the most. The solution obviously compounds the problem, but I've showed that brand new probes coated with solution are not affected. How long these new probes last remains to be seen, but that failed machine that led me down this research path was only a few years old. And then finally, a few outstanding questions that I still have. The touch version, why is the set point on that different to the others? This surely makes this problem even worse. Have they done that on the newer versions of the other, the dual boiler and the Oracle? I've not had any in to check. Maybe you can tell me that. And then those plastic probes that they've moved to on the Gen 3 boilers, why aren't they making some for the rest of us? So if you've got any answers to these questions or you have any others, then leave a comment below.